and welcome to Train Signal. You are watching X11 installation and configuration. As Linux power users, administrators, and Linux Plus certification candidates, we use and must become masters of the Linux command line. This is a necessity as you may encounter servers that don't bother to load a graphical environment at all, plus some troubleshooting and administration tools must be run from the command line. And then there are those times when a user's graphical interface has decided to take a temporary hiatus. The point is that we can't always rely on the GUI to be there when we want or need it. Windows and Mac were the first entrants into the graphical desktop environment race. The windows, the icons, the customizable backgrounds all conspired to make computing fun and more productive for the masses. Linux was admittedly a little late to the party, but in my opinion has made impressive strides in a relatively short period of time. While much of the time you'll simply install your operating system and have things magically configured, every administrator knows that there are times when things go terribly, inexplicably wrong. And it's at these times that you have to roll up your sleeves and dive into the behind-the-scenes configuration that can get things back on track. So in this lesson, we'll talk about the Linux GUI environment, the X window system, which most of the time is simply referred to as X. Then we'll talk about the different configuration tools available. Next we'll get into the details of how to configure X and conclude with a look at configuring X fonts. Let's move on to the next slide, which presents an overview of the Linux GUI environment. So we know that X is Linux's graphical user environment, or GUI. But X handles more than just the display options like video card settings. It is composed of several other hardware components that work with the display, including the mouse and the keyboard. The Linux GUI works with three components. You have the X server, which is responsible for drawing windows on the screen. But you also have the mouse again and the keyboard. I initially wondered why X was called a server, but that's because it can display output locally as well as on any other network system that also runs X. And there are three different types of X servers. The first is X-Free86, which is an early system that isn't used much today. You may find it on systems that need an old or odd driver support. The next is X.org.X11, which is probably the one that most users will have. Now it is based on X-Free86, but it differs in configuration file naming and default font locations. The last type is Accelerated X, which was made by Graphics. Now you probably won't run into this one very much either, but if you're having trouble with a particular video driver, it's one that you can give a try. But X by itself isn't enough. It provides the place to put the windows, but it doesn't control them. And that's where Window Manager comes in. We'll talk about them in more depth in a later lesson, but for now you just need to understand how it fits into the puzzle. So we've got the X server and the Window Manager, and the final piece is the desktop environment. Most will default to GNOME, but the desktop environment actually presents the GUI desktop to the user. Now this handles icon placement, wallpapers, backgrounds, and things like that. Let's take a quick look at our Fedora system to look at the GNOME desktop and some of the settings. So the entire X system again controls things like your menu's windows, the colors, etc. From the main menu, let's click on System, and then click on Preferences and Appearance. From this utility, you can change things like your background, the theme, and even controls your fonts, which we'll talk about in just a minute. As you can see here, you have different themes, and you can simply click on one to select it, and you'll see the changes applied immediately, just in terms of the colors of the windows and the menus, and things like that. I'm going to go back to our custom. And again, the same for backgrounds. There's a list of pre-installed backgrounds that come with the system, and you can also get some more backgrounds online as you see here. And again, simply clicking on one will apply the change, but I'm going to go back to the default. Now that you have a whole view of the Linux GUI and how all the components work together, let's review what the X configuration tools have to offer on the next slide. Let's head back to the presentation. Reading the various Linux support forums is an excellent learning tool for novices and experienced alike. I spent and still spend quite a bit of time doing this every week. One of the most common issues I see on the forums is related to video card drivers. Now, X has its own drivers, but sometimes card manufacturers will have drivers of their own. It's at these times when you may find yourself having to tinker with configurations. And make no mistake, configuring X is not for the faint of heart. The options in the configuration files can be confusing, and one misstep could spell disaster. Because of this, tools have cropped up that can help ease the configuration process. This won't eliminate the possibility that you'll need to manually configure a file, but it does lessen it somewhat. And to further complicate matters, there are of course different tools for different X servers. X server has its own tools, xfree86-configure, or if you have X11, it's xorg-configure. What these tools do is query the hardware and it produces a configuration file. For xfree86, it's located in root xf86config.new, or for X11, it's located in root also, and the name of the file is xorg.conf.new. Now there are also tools for certain distributions. For Fedora, for instance, or other Red Hat derivatives, there is the Display Settings tool, which you can access by typing system-config-display at the command prompt. But there's also a graphical tool. xfree86 also had its own tool, which was called xf86cfg, and that was for 4.x. X11's tool similarly was named xorg-cfg. Now both of these have been deprecated, meaning they aren't used anymore, but they may still be on your system. On my system, which is Fedora 13, the xorg-config commands no longer work. So this is one of those instances where a new release has changed things a bit. Now on your own system, depending on the version, the distribution and the version and release, you may or may not have any of these tools, but for the purposes of certification, you have to know and you have to have an understanding of these tools and their purpose. Let's take a quick look at the graphical version of xorg-configure. Let's switch back over to our Fedora system. Okay, from the main menu, click on System, then Preferences, and then scroll down to Monitors. Again, this is the graphical version of their configuration tool. And you see here that it can detect the number of monitors that you have. Then you have the resolution. And on my system, I have a couple different options. You have the refresh rate, which a lot of times there's only one option, and rotation. Okay, let's close this out and head back to the presentation. If you happen to still have a video card that requires xfree86 3.x versions, the configuration files are xf86config or xconfigurator or xf86 setup. These tools won't handle modifying configuration files for you, but they gather the information that you'll need to do so. Let's continue our look at configuration files on the next slide. Once you've obtained information from one of the configuration tools, you can use that same information to modify your configuration files. As you've probably guessed, configuration files will be different depending on your X server. For X11, the file is xorg.conf and is usually stored in either etc or in etc x11. For xfree86 4.x, there are two possible files. The first is xf86config-4, which is usually stored in etc x11. The second potential file is xf86config, and that's either stored in etc or in etc x11. And for those of you that might still be using the xfree86 3.x server, the configuration file is xf86config, and you can find it in either etc or etc x11. Now let's take a look at the file format on the next slide. Configuration files have several sections for each feature, and the format is essentially what you see on the screen. You'll have the section name, then you'll have an identifier, followed by drivers, some options, and it ends with end section. Now, using the example on the screen, this is for a mouse. You'll have a name of the mouse or an identifier, and this can essentially be anything. Next, you'll have the driver name, which of course depends on the manufacturer of your mouse, any options that you may need to include, and the section is ended with the words end section. Now, since X is often started automatically, you can't very easily test your new settings. Recall when we talked about run levels in the lesson on run levels and system shutdown and reboot? Well, if you remember, there were run levels that you could use to do system maintenance and testing. Well, to test X, you can use run level 3, which will boot the system without the X server loaded. And again, run levels are used on Red Hat derivatives like Fedora. But for Debian-based systems like our Ubuntu test system, you'll need to shut down the GUI with the command etc init.d gdm stop or xdm, depending on your distribution. Then you make the changes that you want to make, and to start X again, you use the command start X. With the latest distributions, the X server now supports the configuration directories etc x11 xorg.conf.d and user share x11 xorg.conf.d. The former is for user-specific configuration, and the latter provides configurations by distribution vendors. So changes in this latter file can be overwritten. So for files in the user-specific configuration directory, the suffix is .conf. And these are parsed by the X server at startup and treated like part of traditional xorg.conf configuration file. Files in this directory can contain one or more sections. The difference is the X server treats this collection of configuration files in the xorg.conf.d directory as one big file, sort of like the entire xorg.conf file. So let's take a closer look at the configuration file sections. The first is the module section, which loads the X server modules or drivers. The section name is module, and the load option is used to load each driver by name. Now, most of the time, you probably won't want to edit this section. Next, we have the keyboard section, and the section name will be input device, but you have an identifier line that you can also use to identify the keyboard, and it's usually keyboard 0, but can be anything you like. In the keyboard section, you'll also have the driver name, and you'll have some options, things like the keyboard layout and the repeat rate. Now, these can be overwritten by any user settings. The next section is mouse, which will also be entitled input device, but has an identifier line where you can identify the mouse by another name, typically mouse 0. Much of this section looks just like keyboard, with the driver name and any options. Another section is for the monitor, which is the tricky section. The name, of course, is monitor, and additional information you'll have in this section is model name, horizontal and vertical sync rates, you've got refresh rates, and then you've got mode lines. The mode lines contain the monitor display options, like the size, for instance 1024 by 768 or 1360 by 1024. And if you set this incorrectly, your monitor will probably not work. Then we have the video card section, and you'll have two sections under this part. The first is called device, and that will contain driver, vendor, and onboard RAM information. You'll also have a screen section, which contains device, monitor, color depth, and other display information. Let's switch back to a terminal window and take a quick look at a keyboard configuration file. Okay, let's open a terminal window. Applications, System Tools, Terminal. Now let's move over to the etc x11 directory so we can take a look at the files and directories there. Let's type in cd space /etc/x, and note that the X is a capital, x11. Now let's type in ls to see what we have. You see that we have both an xorg.conf.d directory and we have an xorg.conf file. Let's check out the xorg file first. Let's type in cat, which will display the contents of a file, space xorg.conf, and hit enter. Scroll back up here so we can see the top. As you can see, we have a section monitor, which contains an identifier, which again could be anything, but it's called monitor 0. We've got model name and vendor name. Now this just tells us that we're using a virtual machine. That's what VirtualBox is. And you'll see the same information for the device, which would be normally the monitor. And again, it's just VirtualBox information. For the screen section, it's titled Display, and that shows our color depth. The current mode is 1024 by 768, and we've got some other identifier information, followed by in section. Now let's switch to xorg.conf.d. We'll type in cd space xorg.conf.d and hit enter. Let's type in ls to see the contents of this directory, which I'm thinking won't be very extensive. And as you can see, we have a keyboard configuration file, and this is just some VirtualBox information that we don't have to worry about. Let's take a look at the keyboard configuration file. Again, let's type in cat space, and we'll just enter the name of the file, 00-setup-keyboard.conf and hit enter. And what we have for the keyboard is an identifier, some other information including model number, we've got the US keyboard layout, and we've got some options for terminate. Okay, let's head back to the presentation. The last section required for both X11 and X386.4.x is the server layout section. Think of it as sort of a catch-all for all other sections of the X configuration file. It usually lists the screen, the mouse, and the keyboard. The section name, again, is server layout. You use identifier to indicate a single or multiple displays. Then you have the screen and you have the two input devices, the mouse and the keyboard, followed by in section. Before we move on, I'd like to reiterate that for certification purposes, you must understand the various X servers and configuration files and settings. But more recent Linux releases may be using other tools to handle X server configuration. Okay, moving on. There is a tool called xdypinfo that will give you all types of technical information about your monitor. Now, I'll warn you that this is a file that is extremely technical, so some of it may not be that easy to decipher. And similarly, if you wanted information about a specific window, you could use the command xwinfo. From the terminal, you type the command and then move the mouse to a window and click. Let's go back to our terminal window and give these a try. Okay, first let's clear our screen with the clear command. And I'm going to switch back to my home directory by just typing in cd. Now let's type in xdpyinfo. Let's make sure we have that spelled correctly, xdpyinfo, and hit enter. Now if we scroll through, let's go back up to the top first. You can see tons of information, some of which will make absolutely no sense, but it's still a good idea to just peruse through here and take a look at some of the information. You got things that you may recognize, like here for the first screen, and in this case the only screen. You've got dimensions, resolution, window, and other information. Again, you can spend some time on your own going through this, but for now we just need to understand the command and what it will do. Now let's try out the next one. But first I'm going to open another window. Let's just open our home directory here by double-clicking, and we'll move that over here to the side. Bring that one back forward. Okay, now let's type in XWININFO. Let's make sure we spelled it correctly and hit enter. Now let's click on this window and you can see the information that popped up. We've got some screen dimensions, the width and height, color information, and other information about geometry that you see here. Okay, now let's try that again. We're going to use it on our terminal window. We'll use the up arrow to bring the command back, and we'll hit enter. Now let's click on this window, and you can see the same information for the window that we have open here. Okay, let's head back to the presentation. One of the things I was least happy about with my early forays into Linux was the font system. Frankly, they just didn't look all that good. And though things have certainly improved, some still feel Linux may be behind some of its competing operating systems. Fonts in the X Windows system are usually automatically set up and can be configured through regular channels, but you do have the option to set up a font server. This server does exactly what the name implies. It can deliver fonts to computers using regular network protocols. But before we talk about configuring fonts, let's take a moment to review the two types of fonts available. The first is bitmap, and this is a term you probably remember from your Windows days. Under this technology, pixels are either active or inactive. Now the problem with these fonts is that each must be optimized at a particular resolution. So what you see on the screen will probably not be what you see on the page. Another issue is that you need to have multiple files to display a single font at multiple sizes. So if you have a 10-point, a 12-point, a 14-point, and more, you'll need several files to display each size. And you can probably imagine how inefficient it is to have that many files for each font. You probably won't have to worry about bitmap fonts very much anymore, as most distributions now either use outline or scalable fonts. And there are two types of scalable fonts. The first is Adobe PostScript Type 1, and the other is TrueType. And with this technology, each character is represented as a series of lines and curves. Since the font is scalable to any size, only one file is required, a huge benefit over bitmap. But there is one problem. The scaling doesn't always produce perfect results, and the display takes slightly more time. Now on modern systems with modern CPUs, this probably isn't much of an issue. Another font category, Xcore fonts, are handled by X, and they require you to create a font directory and add that directory to the font path. Let's take a look at both on the next slide. Typically, fonts are stored in either one of two directories, User Share Fonts or User Share X11 fonts. But if you want to download and add your own fonts, you might want to store them in opt fonts or user local fonts. If you recall from our lesson on Linux file systems, opt and user local are good spots to store programs you download and install yourself. If you use Type 1 fonts, you'll need to look for file names that end in PFA or PFB. For TrueType fonts, the extension will be TTF. Let's quickly switch over to our terminal window and see where fonts are stored on our test system. Okay, first let's close this window, get that out of the way. We'll move this back down. Now let's check and see if fonts are in User Share Fonts. To do this from here, all we need to do is type in the ls command, which will display the contents of a directory. We just type in the directory name, User Share Fonts, and hit enter. And we can see we have our fonts here. We have some that we may recognize and quite a few others that we may not. Let's see if we have anything in the other directory. Let's type in ls space user share x11, and don't forget to capitalize the X, /fonts, and hit enter. And it looks like we don't have much there, so we see that our main font directory is User Share Fonts. Let's head back to the presentation. Once you've copied the files to the correct location, you need to create the font summary file, and you do so with the mkfont scale and mkfontdir commands. The first reads all the fonts in the current directory and then creates a file called fonts.scale. This includes only outline fonts, and that's type 1 and true type. Then mkfontdir combines font.scale with fonts.dir, or creates it if it doesn't already exist. And each font type has their own programs as well. ttmkfdir is for true type fonts, and type 1 inst is for type 1 fonts. But you'll probably just want to use the program that handles both type of files. So now you have the files downloaded and copied to the appropriate directory, and you've also created the fonts.dir file. Now the only thing left to do is to modify the path. To do this, edit the File section of xf86config or xorg.conf. Just copy one of the existing lines, paste it, and change the path to point to your new fonts directory. For example, under the File section, you'd have a new entry that says Font Path and have that set to User Local Fonts. Once you've made the changes we just discussed, the next logical step is to test it out. You could shut down and restart X as we discussed on one of our previous slides, or you could try the xset program. The syntax is xset space fp plus followed by the path, which is User Local Fonts, which adds your new font directory to the end of the current font path. And xset fp rehash instructs X to take another look at all the fonts directories on the path in order to rebuild a list of available fonts. xfontsel will also let you pick a font for display, so you can quickly check out how things will look before you apply any changes. Not many distributions use a font server, but if you want to use one, you have to list the server in the font path. Because Xcore fonts still have a problem, namely poor screen-to-print integration, problems with kerning and smoothing, and other issues, XFT fonts were created, which supports all of these things. The problem of having two font systems isn't really an issue, as you can share font directories just by editing etc fonts local.conf to add the new directory, and then you run fc-cache as root to create index files, which are similar to the font.dir file. And that concludes our lesson on X11 installation and configuration. Let's review what we've covered on the next slide. I'm betting you've learned more than you ever thought possible about configuring Linux displays. You're not alone. I too was surprised by the depth and level of detail in this topic. One thing that I'd like to leave you with is that in the open source community, the software development cycles are much faster than their commercial counterparts. And as such, tools, configuration options, and programs can change in small ways or drastically from one release to the next. We saw an example of that in this section. As with Fedora 13, the X configuration files have changed. Still, in preparation for the Linux Plus certification exam, this is material that we really need to understand. In this lesson, we reviewed the Linux GUI environment and its components, the X server, the desktop manager, and the desktop environment. We then covered the configuration tools that help you gather information about your display system's hardware and settings. Next, we covered how to configure both X and X's fonts. Thanks for watching, and I'll see you in the next lesson.